Picture this, a world without glass lenses, without digital screens, without any of the sophisticated instruments we take for granted today. The only thing standing between humanity and the infinite mystery of the night sky was the ground beneath our feet. For thousands of years, our ancestors looked up at the same stars we see now, but they did something extraordinary. They began to measure the cosmos using nothing but stone. They arranged rocks into circles, aligned massive slabs with the rising sun, and carved symbols into cliffs to track the dance of planets and the passing of seasons. This was the birth of astronomy, long before the telescope was even a dream, and it all started in what we might call the Astronomers Quarry. That term might sound unusual at first, but it perfectly captures the ingenuity of these early sky watchers. They didn't have observatories, they had landscapes. They didn't have written charts, they had standing stones that served as both calendar and cathedral. From the windswept plains of ancient Britain to the sun-baked deserts of the Americas, cultures across the world independently discovered how to use stone to decode the universe. These weren't random piles of rock, they were carefully engineered instruments designed to capture specific moments of light, shadow, and celestial motion. They helped societies plant crops, mark sacred days, and navigate vast territories, but they also answered a deeper, more human need to find meaning in the stars. In this video, we're going to journey back through time to explore how stone became humanity's first tool for understanding the heavens. We'll visit iconic sites like Stonehenge and Newgrange, where solstice sunrises still illuminate chambers built over 5,000 years ago. We'll uncover the methods and myths that guided ancient astronomers, and we'll see how their legacy influences the way we look at the sky today. This is more than a history lesson. It's an invitation to see the night sky through the eyes of the past, to stand beside those ancient observers and share in their wonder. So let's begin this adventure into the Astronomer's Quarry, where every stone has a story and the universe feels closer than you might ever have imagined. There is a moment in human history so distant that it predates cities, writing, and even agriculture, a moment when our ancestors first looked up at the night sky, not just with wonder, but with a dawning sense of order. This was the true beginning of astronomy, a story written not in books but in the very landscape. Long before the first telescope was conceived, these early observers recognized that the heavens were not a random scattering of lights. They saw that the sun returned to the same point on the horizon in a reliable cycle, that the moon waxed and waned in a predictable rhythm, and that certain stars heralded the changing seasons. This wasn't merely about curiosity, it was about survival and meaning. Their first tools were the world itself, a notch in a distant mountain peak that captured the solstice sunrise, a peculiarly shaped tree that lined up with the full moon, a solitary boulder that cast a telling shadow on the equinox. These natural landmarks became the first astronomical markers, a way to anchor the vast, incomprehensible cycles of the cosmos to the familiar ground beneath their feet. But this passive observation soon evolved into something far more intentional. Communities began to actively shape their environment to better reflect and measure these celestial patterns. They started moving stones, carefully selecting and placing them to create permanent, unmistakable alignments. Imagine the effort and shared purpose this required: the collective decision to drag a heavy slab of rock into a precise position so that, for just a few days each year, the rising sun would kiss its edge or shoot a beam of light through a specially designed gap. This practice fused the practical with the profound. On one hand, these stone calendars were essential for knowing when to plant crops, when to migrate with herds, or when to expect the return of vital resources. They were the ancient world's most reliable almanac, etched not on paper but in granite and sandstone. On the other hand, they were temples under the open sky. These alignments connected the community to the divine, turning the annual solar and lunar events into powerful spiritual experiences that reinforced cultural bonds and cosmological beliefs. The cycle of the heavens became the heartbeat of their society. One of the most breathtaking and ancient examples of this is found not in Europe, but in the Sahara Desert. At a site called Plier in what is now southern Egypt, a group of cattle-herding people constructed a stone circle and multiple alignments over 7,000 years ago. That's older than Stonehenge by millennia. The stones at Plier are not particularly large or dramatic to look at, but their arrangement is brilliantly sophisticated. They were carefully positioned to align with the rising points of key stars, particularly those of Orion's belt and Sirius, the brightest star in our night sky. These celestial events would have signaled the coming of the annual monsoon rains, a matter of life and death in that arid environment. This makes Plier far more than a calendar. It is one of the world's first known astronomical observatories, a testament to the fact that the drive to decode the universe is a fundamental part of the human story, emerging independently across the globe with nothing but intellect, patience, and stone. These early efforts laid a foundation of knowledge, a deep understanding of cyclical time that would be passed down through generations, setting the stage for the even more complex astronomical monuments that would follow. So what exactly do we mean by the term Astronomers Quarry? It's a concept that goes far beyond a simple pile of rocks. Think of it not as a place where stone was extracted for building, but as a living, breathing toolkit, a collection of natural and human-modified stones that were deliberately chosen and arranged to become permanent astronomical instruments. These weren't just random markers, they were the key components in an ancient observatory without walls. The quarry wasn't a single location, but rather the entire landscape, selectively curated by generations of sky watchers who understood its potential. They looked at a particular boulder, a cliff face, or a solitary hill not for what it was, but for what it could do, how it could frame a celestial event, cast a specific shadow, or serve as a fixed point on a giant, earthly measuring device. The selection process for these stones was incredibly thoughtful. Durability was paramount. These instruments had to last for centuries, enduring weather, erosion, and the passage of time to ensure the astronomical knowledge they encoded would be preserved for future generations. This is why we still find them today, but placement was even more critical. A stone might be chosen because it already stood on a natural ley line, or because its position on a hilltop provided an unobstructed view of the horizon. Sometimes the local geology itself offered unique advantages, a specific type of rock that gleamed in the moonlight, or a natural fissure that perfectly aligned with the winter solstice sunset. The ancients weren't fighting their environment. They were collaborating with it, weaving their celestial calculations directly into the fabric of the natural world. This practice resulted in the creation of vast, open-air laboratories, from the mighty standing stones of Karnak in France to the intricate spiral petroglyphs carved into the canyons of the American Southwest. These sites became the meeting point of sky and earth. They functioned with a precision that is still impressive today. A carefully positioned stone could act as a back sight for an observer, lining up with a distant foresight to pinpoint the exact location on the horizon where the sun would rise on the longest day of the year. A series of smaller rocks could count the days between lunar phases. Some of the most sophisticated arrangements even seem to have been used to predict eclipses, those awe-inspiring events that could terrify or delight a population. This was a profound fusion of empirical science and deep mythology. The stone that marked the solstice wasn't just a measuring stick. It was often seen as a conduit for spiritual energy, a physical anchor for a deity's journey across the sky, or the petrified body of an ancestor who held up the heavens. Ultimately, understanding the concept of the Astronomer's Quarry allows us to fully appreciate the sheer ingenuity of our ancestors. They possessed no telescopes, no written star charts, and no digital calculators. Yet, by using the landscape itself as their tool, they achieved a sophisticated understanding of cosmic cycles. They turned their entire world into a clock, a calendar, and a map of the heavens. This was astronomy in its most elemental and beautiful form, a dialogue between human curiosity and the eternal patterns of the universe, all mediated through the enduring medium of stone. What's truly remarkable is how this celestial conversation with stone emerged separately, yet simultaneously, in cultures that had no possible contact with one another. It speaks to a shared human impulse, a universal need to find order in the cosmos and reflect it here on Earth. But while the medium stone was common, the meanings and methods were wonderfully diverse, each culture painting its own unique cosmology onto the canvas of the sky. In the Fertile Crescent of Mesopotamia, the cradle of civilization, they didn't arrange standing stones in circles. They built upwards towards the gods. Their instruments were the magnificent Zigurates. These massive, stepped pyramids were far more than just temples or administrative centers. Their soaring heights lifted priests and astrologers above the flat plains, providing an unobstructed platform for observing the horizon. From these elevated vantage points, they meticulously tracked the movements of planets like Venus and Jupiter, which they associated with powerful deities. Their observations, often recorded on clay tablets, were deeply entwined with omens and divination, used to advise kings and predict the fate of the empire. The ziggurat was a stairway to heaven, a man-made mountain of baked brick that served as both spiritual conduit and the world's first astronomical viewing platform. Meanwhile, on the other side of the world, ancient Chinese astronomers were developing a philosophy of cosmic harmony, and they often used jade and stone to embody it. For them, the universe operated on a principle of order known as the mandate of heaven, and astronomical events were direct messages about that order. While they later built sophisticated bronze instruments, their earliest practices involved jade by discs, flat circles with a central hole which some scholars believe represented the heavens themselves. They also erected stone pillars to measure the sun's shadow and track the seasons with incredible precision for the agricultural calendar. This wasn't just about practicality, it was a sacred duty. The emperor himself was considered the link between heaven and earth, and accurately reading the sky through these stone and jade tools was essential for maintaining balance and legitimacy in the realm. Their entire system of governance was, in a way, built upon a foundation of celestial observation. Crossing the Pacific to North America, we find a completely different expression of this same human drive. Indigenous cultures from the Great Plains to the desert Southwest integrated astronomy into the very land. The medicine wheels of the northern plains, like the famous Big Horn medicine wheel in Wyoming, are intricate arrangements of stones radiating from a central cairn. These spokes align with the rising and setting points of key stars like Sirius and Aldebaran, acting as a calendar to signal the timing for ceremonies, hunts, and seasonal migrations. Further south, the ancestral pueblones of Chaco Canyon carved precise spiral petroglyphs onto high cliff faces. The most famous of these, the sun dagger, uses a clever interplay of sunlight and shadow. On the summer solstice, a single dagger of light perfectly bisects the center of the spiral, and on the winter solstice, two daggers of light frame it. This was public astronomy, a spectacle that connected the entire community to the cosmic cycle. blending science with spiritual ritual in a way that guided their daily lives and agricultural practices. The individuals who held this sacred knowledge were the learned elders, the shamans, and the priestly classes. They were the human libraries of their time, entrusted with millennia of observational data passed down not through books, but through intricate oral traditions, stories, songs, and direct apprenticeship. A young initiate might spend years accompanying an elder to a stone circle, learning not just that a star rose over a certain rock, but the stories, prayers, and community laws that were tied to that event. This knowledge was power, not power for domination, but power for survival and cultural continuity. It dictated when to plant corn, when to hold a coming-of-age ceremony, and how to navigate vast territories using the stars as a guide. This incredible diversity, from the towering Zigurates of Mesopotamia to the subtle sun daggers of Chaco Canyon, proves that the desire to understand the heavens is a fundamental thread in the human story. Stone was simply the most permanent and powerful language we had to write that story down. The true genius of these ancient astronomers lies not in the stones themselves, but in the remarkably sophisticated methods they developed to use them. Without the benefit of advanced mathematics or complex tools, they devised a system of celestial observation that rivals modern precision in its own way. At the heart of this system was a profound understanding of geometry and a deep generational patience. Their primary instrument was often the simplest of things, a single, upright rod or pillar known as a Nomen. This unassuming tool was the cornerstone of their craft. By carefully observing and measuring the length and direction of the shadow cast by a Nomen over the course of a day and throughout the year, they could map the sun's journey across the sky with stunning accuracy. The shortest shadow of the day would point directly north at local noon, while the longest and shortest shadows of the entire year marked the solstices, the pivotal turning points of the solar cycle. This simple principle transformed a stick in the ground into a sophisticated solar calendar and compass. Building upon this basic concept, they established permanent sighting lines. This is where the stones became permanent, immutable records of their knowledge. Instead of relying on a wooden pole that could rot or be moved, they would erect massive, unmovable stones to serve as both foresights and backsights. An observer would stand at a specific viewing stone and look past one or more aligned stones toward a precise point on the distant horizon. The most critical alignments were reserved for the solstices and equinoxes. They knew that the sun does not rise and set in the same place every day. It travels along the horizon throughout the year. The summer solstice sunrise marks its northernmost point, while the winter solstice sunrise marks its southernmost extreme. By placing a large stone to exactly frame that first sliver of sun on the shortest or longest day of the year, they created a permanent celestial event marker that would function perfectly, year after year, century after century. The famous heel stone at Stonehenge is a perfect example of this. For an observer standing at the center of the circle, the midsummer sun rises directly over its top, a spectacle that still draws thousands of people every year to witness this ancient accuracy. But their ambitions stretched far beyond the sun. They also turned these stone arrangements towards the moon and the stars, which required even greater precision and a much longer timeline of observation. The moon's cycle is more complex than the sun's. It has its own more subtle wobble, known as the lunar standstill, which only completes its full cycle every 18.6 years. To accurately track this required observations that spanned multiple human lifetimes. At sites like the Callanish stones in Scotland, the ancient builders arranged monoliths to frame the extreme rising and setting points of the moon during this long cycle. This means that a single generation would have to carefully record the moon's movements and then erect stones based on that data. trusting that their grandchildren's generation would be there to continue the work and verify the alignments. This represents an incredible investment in long-term knowledge, a chain of observation and tradition that connected communities across centuries. They also mastered the art of light and shadow in more intricate ways. At Machu Picchu in Peru, the Intihuatana stone, often called the hitching post of the sun, is a marvel of this principle. This intricately carved granite pillar was not just a symbolic object, it was a precise astronomical instrument. On the equinoxes, the sun stands directly overhead at noon and casts no shadow at all. Throughout the rest of the year, the shifting angles and lengths of its shadows would have told skilled observers exactly what time of year it was, effectively making it a sophisticated solar clock. Similarly, the sun dagger petroglyph in Chaco Canyon uses a natural rock formation. Sunlight passes between two massive stone slabs and projects a dagger of light that moves across a spiral carving, perfectly bisecting it on the solstices and framing it on the equinoxes. This method shows a move from simple alignment to a more theatrical, yet no less precise, form of measurement that engaged the entire community. The cumulative result of all these methods, nomens, sighting lines, and light play, was the creation of incredibly accurate calendars. These stone calendars were more reliable than any early human-made timekeeping device, governing agriculture, religion, and social structure for millennia, all achieved through nothing more than careful observation, a deep understanding of the land, and the enduring power of stone. Rising from the Salisbury Plain in England, Stonehenge is more than just a ring of standing stones. It is a monumental puzzle that has captivated humanity for thousands of years. Its iconic silhouette against the sky is instantly recognizable, but to truly appreciate its genius, we must look beyond the familiar postcard image and understand it as a sophisticated astronomical instrument crafted from stone. The central axis of the entire monument is meticulously aligned on a northeast-southwest line that precisely captures the summer solstice sunrise in one direction and the winter solstice sunset in the other. This was no happy accident. For an observer standing at the exact center of the circle during the dawn of the longest day of the year, the first golden sliver of the sun would appear to rise directly over the outlying heelstone, a massive, weathered sarsen that seems to stand sentinel to this celestial event. This alignment transforms the entire architecture from a static arrangement into a dynamic, interactive calendar, marking the sun's most extreme northern and southern journeys with a breathtaking, predictable spectacle. But the sun was only part of the story. While the solar alignments are the most famous and publicly accessible, the monument's relationship with the moon reveals an even deeper layer of astronomical understanding. The moon's path across the sky is far more complex than the sun's, undergoing a subtle long-term wobble known as a major lunar standstill, which only occurs every 18.6 years. Intriguingly, the four station stones that form a small rectangle around the main circle appear to be aligned with the extreme rising and setting points of the moon during this rare event. Furthermore, recent archaeological surveys and computer models suggest that some of the smaller blue stones, transported all the way from the Preseli Hills in Wales, might have been arranged to help predict eclipses, those awe-inspiring moments when the sun and moon briefly align to blot each other out. The idea that Neolithic people could not only track but also anticipate these terrifying and wondrous celestial dramas speaks to a level of intellectual sophistication we are only just beginning to fully comprehend. The sheer physical effort involved in its construction is a testament to the overwhelming importance of this cosmic connection. The largest of the sarsen stones weigh up to 30 tons each and were dragged over 20 miles from the Marlborough Downs. The smaller bluestones undertook an even more epic journey of nearly 150 miles from Wales. The logistics of this endeavor are staggering, requiring a highly organized society with a shared, powerful motivation. This was not a project undertaken for mere shelter or defense. It was a generations-long act of faith and science, a permanent inscription of celestial order onto the landscape. The society that built Stonehenge was clearly one that placed supreme value on understanding the rhythms of the cosmos, likely seeing the sun, moon, and stars as direct manifestations of divine forces that governed their agriculture, their rituals, and their very existence. Ultimately, Stonehenge stands as a timeless symbol of humanity's quest for meaning in the heavens. It functioned simultaneously as a precision calendar for planting and harvest, a cathedral for spiritual ceremony, and a social gathering place that unified a widespread culture. Its enduring power lies in this beautiful multiplicity of purpose. It reminds us that for our ancestors, astronomy was not a separate, abstract science, but was woven into the very fabric of their daily lives, their beliefs, and their relationship with the world around them. The stones continue to whisper their secrets, challenging us to understand the brilliant minds that, without any of our modern technology, managed to capture the cycles of the cosmos in a circle of enduring stone. While Stonehenge captures the imagination with its towering stones under the open sky, another site on the other side of the Irish Sea demonstrates an equally profound but entirely different approach to celestial architecture. This is Newgrange, a massive, grass-covered mound that from the outside looks like a gentle, rolling hill. But to step inside is to enter a 5,000-year-old machine built for one breathtaking moment of cosmic alignment. The heart of Newgrange is a long, narrow passageway that leads to a central cross-shaped chamber deep within the earth. This passage is precisely oriented toward the southeast, and above its entrance sits a feature found nowhere else in the world, a unique roof box. This is a small, window-like opening carefully constructed with massive stone slabs, and it serves one extraordinary purpose. For just a few days around the winter solstice, when the sun is at its very lowest and weakest point in the sky, a beam of light will enter this roof box and travel down the dark passage, eventually flooding the inner chamber with a warm, golden light for approximately 17 minutes before retreating once more into darkness. The precision required to achieve this is almost beyond belief. The builders had to calculate the exact angle of the midwinter sunrise, the gradual slope of the passage floor, and the height of the roof box opening to ensure this narrow beam of light would travel nearly 24 meters of total darkness to reach its destination. They did this without any written language, without metal tools, and with only a deep, generational knowledge of the sky's movements. This was not a public spectacle like the sunrise over Stonehenge's heel stone. This was an intensely private, spiritual event witnessed by only a select few who could fit inside the chamber. The symbolism is powerful and immediate. At the darkest, coldest time of the year, when the world seems to be dying, the sun itself is invited into this house of the dead, piercing the darkness to promise renewal, rebirth, and the inevitable return of life and warmth. It is a stunning theatrical demonstration of the triumph of light over darkness, engineered in stone. The artistry within Newgrange deepens this spiritual connection. The stones lining the passage and chamber are not merely functional, they are a canvas covered in intricate megalithic art. The most common motifs are spirals, concentric circles, and zigzags, carved with painstaking effort into the hard rock. While their exact meaning is lost to time, many researchers believe these are not mere decorations. The spirals could represent the sun's journey, the cycles of the seasons, or even the cosmos itself, a visual language linking the astronomical function of the tomb to a broader cosmology. These carvings transform the entire structure from a simple tomb into an illustrated manuscript of stone, where art, astronomy, and ancestor worship are completely intertwined. The people who built Newgrange were not just tracking the sun, they were weaving its cycle into their beliefs about life, death, and what lies beyond. This fusion of the practical and the profound is what makes Newgrange such a powerful example of the Astronomer's Quarry. It showcases how ancient cultures used their understanding of celestial mechanics to feed not just their bodies, but their souls. The winter solstice alignment provided a fixed, unmovable point in the calendar, a promise that the sun's power would return and that the cycle of agriculture could begin again. But it also provided a profound spiritual comfort, connecting the community to their ancestors buried within the mound and to the cosmic forces that govern their universe. Newgrange is a timeless reminder that for our Neolithic ancestors, science and spirituality were not separate fields of inquiry, but two sides of the same coin, both essential for understanding humanity's place in the great cosmic order. Leaving behind the green hills and enclosed chambers of Europe, we journey now to a starkly beautiful and sun-drenched landscape, the high desert of the American Southwest. Here, in what is now New Mexico, the ancestral Puebloan people created one of the most sophisticated and expansive cultural centers in ancient North America, Chaco Canyon. At first glance, the canyon might seem an unlikely place for a thriving civilization. It is an arid, challenging environment where water is scarce and the summers are scorching. Yet, between the 9th and 12th centuries, this place blossomed into a hub of extraordinary architecture, trade, and scientific observation. The Puebloans did not just survive here, they engineered a society in profound harmony with the cosmos, using the canyon's towering rock faces and vast open skies as their astronomical canvas. Their greatest tools were, once again, the stones beneath their feet and the sunlight that bathed them. The most famous and elegant example of their celestial genius is the Sun Dagger petroglyph. High atop Fajoda Butte, a dramatic sandstone spire that dominates the canyon floor, three large stone slabs lean against the cliff face. Behind them, ancient artists carved a spiral petroglyph into the rock. For most of the year, this spiral is simply a static piece of art, but on the summer solstice, something magical happens. As the sun reaches its zenith, a slender dagger of sunlight appears, slicing perfectly through the center of the spiral. On the winter solstice, two daggers of light appear, precisely framing the spiral on either side. And during the equinoxes, a single dagger of light bisects a smaller, nearby spiral. This is not a crude alignment. It is a breathtakingly precise and dynamic solar calendar, a light show orchestrated by the Earth's rotation and ingeniously framed by human hands. It transformed a remote cliffside into a public observatory, a place where the entire community could visually confirm the turning points of the year. But the sun dagger was just one part of a much larger, integrated astronomical system. The Puebloans constructed massive, multi-story great houses like Pueblo Bonito and Chetroquetl, with walls and windows that are meticulously aligned to cardinal directions and to significant celestial events. Some scholars believe that certain corner windows were designed to capture the first light of the rising sun on the solstices, casting a beam of light across specific interior spaces to mark these sacred days. The entire layout of the canyon itself, with its network of perfectly straight roads radiating outwards for miles, suggests a grand, coordinated design that may have also held astronomical significance, connecting outlying communities to the central ceremonial calendar of Chaco. This was astronomy on a civic scale, woven into the very urban planning of their society. The driving force behind this precise celestial observation was deeply practical. In an environment where a miscalculated planting season could mean starvation, knowing the exact dates of the solstices and equinoxes was a matter of survival. The sun cycles dictated the timing for planting corn, beans, and squash, and for preparing for the scarce winter months, but it also governed their spiritual and social world. These celestial events marked the times for major ceremonies, for gatherings of distant clans, and for coordinating trade networks that stretched from the Pacific coast to the Gulf of Mexico. The knowledge of the skies, encoded in stone and architecture, was the glue that held this far-flung culture together. It allowed them to not only endure but to flourish for centuries in a harsh land, creating a legacy of resilience and intellectual achievement that continues to inspire awe and respect for their deep understanding of the world. While the peoples of Europe and North America were building their circles and carving their spirals, a parallel astronomical revolution was unfolding in the lush rainforests and high-altitude basins of Mesoamerica. Here, the Maya and the Aztecs developed some of the most complex and precise cosmological systems the world has ever known, all without the benefit of metal tools or the wheel. Theirs was a universe in constant dynamic motion, and they built their cities to be the stage upon which this celestial drama played out. Unlike the open circles of the north, their observatories were often towering stone pyramids, reaching toward the heavens to get a clearer view of the gods they believed lived in the stars. The most compelling architectural evidence of this is El Caracol, a unique structure at the Mayan city of Chichen Itza. Its name, meaning the snail, comes from the spiral staircase inside, but its form is unmistakably that of an observatory. This isn't a pyramid with a temple on top. It's a cylindrical tower set on a broad, two-tiered platform with narrow window-like slots carved into its walls. For decades, archaeologists debated its purpose, but modern alignments have confirmed a stunning truth. These slots are not random. They are precisely aligned with the extreme rising and setting points of Venus. To the Maya, Venus was not just a bright star. It was Kukulkan, the feathered serpent god, a deity of immense power and significance. Its cycle, which alternates as the morning and evening star, was meticulously tracked because its appearances were believed to influence warfare, the fate of kings, and the timing of sacred rituals. El Caracol was a sophisticated machine of stone designed to monitor the movements of a god. But the Maya didn't stop at architecture. They were voracious record keepers, developing the most advanced writing system in the Americas. While many of their bark paper books, known as codices, were destroyed by time and conquest, a few survived, and they are filled with astronomical tables of breathtaking accuracy. The Dresden Codex, for instance, contains detailed charts that predict the cycles of Venus with an error of just 1 day in 500 years. It also includes tables for predicting solar eclipses and tracking the movements of Mars and Mercury. This data wasn't just academic, it was the foundation of their statecraft. Priests astronomers used these celestial events to advise rulers on when to wage war, when to crown a new king, and when to conduct the sacrifices needed to keep the cosmos in balance. Their understanding of time was also profound, interweaving multiple calendars, a 260-day sacred cycle, and a 365-day solar year into a grand calendar round that took 52 years to complete. This intricate system allowed them to place any event within a vast, repeating cosmic framework. The Aztecs, who rose to power later, inherited and adapted much of this Mesoamerican astronomical knowledge. Their most famous artifact, the massive Aztec calendar stone, is often mistaken for a functioning calendar. While it is a symbolic masterpiece rather than a practical tool for observation, it is a complete cosmology carved in basalt. At its center is the face of the sun god Tanatia, representing the current era of creation. Surrounding him are concentric rings filled with symbols that detail the 5 previous worlds, or suns, that were destroyed, and the 20-day signs of the sacred calendar. It also depicts the symbols for the equally important 52-year cycle, the time it took for the solar and sacred calendars to realign a period that culminated in the terrifying New Fire ceremony, where all fires were extinguished and relit from a single sacred source to ensure the sun would rise again and the world would continue. This stone was a constant physical reminder that the universe operated on precise cyclical time, and that human ritual was essential to maintaining its order. For both the Maya and the Aztecs, stone was far more than a building material. It was an interface with the divine. A pyramid was not just a platform to see the stars, but a symbolic mountain connecting the underworld, the earthly realm, and the heavens. A carved stela recording a king's birth and accession was not just a history but an event anchored in cosmic time, ensuring his legacy would be part of the eternal cycle. Their astronomical achievements reveal a world where science and spirituality were inseparable. Every planetary movement was a divine message, every eclipse a moment of potential cosmic crisis, and every stone structure a vital tool for interpreting the will of the gods and ensuring the continued survival of their world. While the Mesoamerican cultures looked to Venus and complex calendar rounds, the ancient Egyptians turned their gaze to a different set of celestial guides, weaving astronomy into the very bedrock of their civilization with a grandeur that still leaves us breathless. Their entire worldview was built upon a fundamental concept they called Mat, which represented order, balance, and truth, a cosmic harmony that was reflected in the predictable, cyclical motions of the stars and the sun. To maintain this order was the primary duty of the pharaoh, and they used the most permanent material available, stone, to build a civilization perfectly aligned with the heavens. This wasn't just about marking time, it was about creating a divine mirror on earth, a reflection of the perfect, unchanging realm of the gods above. The most iconic examples of this are, of course, the pyramids of Giza. The precision of their construction is still a source of wonder and debate today. The Great Pyramid's base is almost a perfect square, with its sides aligned to the 4 cardinal directions north, south, east, and west, with an error of less than 1/15 of a single degree. To achieve this, Egyptian architects almost certainly used astronomical methods, likely tracking the shadows of a Nomen to find true north or sighting on specific circumpolar stars that never set. But the alignments go far beyond the basic 4 directions. The pyramid's so-called air shafts are narrow passages leading from the king's and queen's chambers deep inside the structure. For a long time, their purpose was a mystery, but we now know they are precisely targeted at specific stars. The southern shaft from the king's chamber pointed directly toward the belt of the constellation Orion, which the Egyptians associated with Osiris, the god of the afterlife and rebirth. The northern shafts aimed at the circumpolar stars, which the Egyptians called the imperishable ones because they never disappeared below the horizon. This was a profound piece of spiritual engineering. The belief was that upon death, the pharaoh's soul would travel up these shafts to join Osiris in the stars, ensuring his eternal life and, by extension, the continued stability and order of Egypt itself. The pyramid was not just a tomb, it was a launchpad for the soul, a stone rocket aimed at the heavens. This celestial connection extended far beyond the pyramids to the great temple complexes that dotted the Nile. The Temple of Amun-Ra at Karnak is a stunning example. Its entire layout is a carefully orchestrated astronomical instrument. The main axis is aligned so that on the winter solstice, the setting sun would cast its light directly down the long hallway of columns and into the deepest, darkest sanctuary, illuminating the statue of the god within. This annual event transformed the architecture into a participant in a divine drama, physically demonstrating the sun god's journey into the underworld and his promised return. Even the humble obelisk, those tall, tapered stone spires that now stand in cities around the world, were originally sophisticated shadow clocks. Their four sides faced the cardinal directions, and by carefully observing the moving shadow its peak cast on the ground, priests could accurately tell the time of day, dividing sunlight into hours for the precise timing of daily rituals and offerings that were essential for keeping Maat in balance. This meticulous timekeeping was the engine of the state. The annual flooding of the Nile was the lifeblood of Egypt, and it coincided predictably with the heliacal rising of the star Sirius. The moment it first becomes visible just before dawn after a period of being hidden by the sun's glare. The Egyptians called this star Sopdet, and its appearance heralded the coming inundation, the new year, and a time of great celebration. By carefully observing this and other celestial events, the Egyptian calendar became one of the most accurate in the ancient world, governing everything from agriculture to tax collection to religious festivals. The pharaoh's power was therefore directly derived from this astronomical order. His ability to predict the Nile's flood and to perform rituals at the exact correct celestial moment proved his divine mandate to rule. In ancient Egypt, stone astronomy was the ultimate expression of power, faith, and a deep, abiding belief that humanity's destiny was written in the stars. Far to the east, in the river valleys of ancient China, a different astronomical philosophy was taking root, one that valued meticulous record-keeping and saw cosmic order as the very foundation of a harmonious society. Here, the relationship between stone and sky was not expressed through towering stone circles, but through exquisite, polished jade artifacts and precisely carved stone pillars. For the Chinese, astronomy was a state science, an essential tool for the emperor to understand the mandate of heaven and to rule with virtue and wisdom. This wasn't just about observing the stars. It was about aligning human civilization with the immutable laws of the cosmos, and they used the most durable materials available to inscribe these laws for eternity. Some of the most intriguing instruments from this tradition are the jade discs. These are flat, donut-shaped rings, beautifully polished with a central hole. While their exact function is still debated by scholars, many believe they held profound astronomical and cosmological significance. The perfect circle of the Bai was thought to represent the heavens themselves, while the square Earth was often symbolized by a different jade object called a Kong. Together, they embodied the ancient Chinese concept of a round heaven covering a square Earth. It's possible that these jade discs were not just symbolic, they may have been used as simple sighting tools. An astronomer could hold one up to the sky, aligning the central hole with a specific star, effectively creating a primitive but elegant aiming device. The use of jade, a material revered for its purity and durability, underscores the sacred nature of this celestial work. It was a material fit for kings and gods, used to measure the movements of the heavens. For more practical, large-scale observations, Chinese astronomers turned to massive stone and masonry constructions. Long before the famous Beijing Ancient Observatory was built with its bronze instruments in the Ming Dynasty, there were earlier observatories that relied on stone pillars and markers to track the motions of the sun, moon, and planets. These pillars, known as Nomen or Biaro, were erected in precise alignment to cast shadows of a specific length at noon on the solstices and equinoxes. The most famous set of these was established by the brilliant astronomer Guo Shaojing during the Yuan dynasty. By meticulously measuring the length of the longest and shortest shadows of the year, they could calculate the solar year with incredible accuracy, even correcting the calendar to improve agricultural planning. This was astronomy in service to the state and its people, ensuring the emperor could accurately predict the seasons and demonstrate his harmonious connection to the natural world. But perhaps the most remarkable contribution of Chinese astronomy is its unparalleled written record, much of it preserved on, you guessed it, stone. Chinese court astronomers were obsessive documentarians. For millennia, they kept detailed logs of every unusual event in the sky. They carved records of comets, solar eclipses, and most spectacularly, guest stars, what we now know to be supernova, onto stone tablets and stelae. The most famous of these is the record of the supernova of 1054, which created the Crab Nebula. Their description of this guest star was so precise that modern astronomers were able to identify its remnant centuries later. This created the longest continuous astronomical record in human history, a priceless dataset that scientists still use today to study the long-term behavior of stars and other celestial phenomena. This practice of carving observations in stone guaranteed their preservation through wars, fires, and the decay of paper and silk, showcasing a profound commitment to preserving knowledge for future generations. This entire system was deeply interwoven with the philosophical and political fabric of ancient China, particularly Confucianism. The Confucian ideal of harmony and order was reflected in the predictable movements of the heavens. A sudden comet or an unexpected eclipse was not just a celestial event, it was an omen, a message from heaven that the emperor's rule might be falling out of alignment with the cosmic order. It was the astronomer's sacred duty to interpret these signs and advise the court accordingly. This gave astronomers immense political influence, but also placed a heavy burden of accuracy upon them. A miscalculation could be seen as a failure to understand the will of heaven, with serious consequences. This unique blend of precise empirical observation, philosophical depth, and state function created a brand of astronomy that was both highly advanced and utterly inseparable from the culture that nurtured it, all captured in the enduring language of jade and stone. Now let's journey to a land of ancient wisdom, where the very contours of the earth and the patterns of the stars are woven together into a living map. In Australia, Aboriginal cultures developed one of the most sophisticated and holistic systems of knowledge the world has ever known. A system where astronomy is not a separate science, but the very thread that binds story, law, and land into a single, interconnected whole. At the heart of this system are the songlines, also known as dreaming tracks. These are not mere paths across the continent. They are intricate oral maps, epic songs that describe the journey of ancestral creator beings during the dreamtime. Each hill, river, waterhole, and distinctive rock formation along the route is a stanza in this vast, sung narrative. Critically, these landscapes are also mirrored in the sky. The movements of stars, planets, and constellations above are sung about in the same sequence as the geographical features below. A navigator walking a songline would sing the verses of the song, and each verse would correspond to a specific location on the ground and a specific star or celestial event overhead. By knowing the song and observing the sky, they could traverse thousands of miles across unfamiliar territory with pinpoint accuracy, guided by the stars that were forever tied to the story of the land beneath their feet. This celestial knowledge was made permanent and tangible through deliberate stone arrangements. Across the Australian landscape, one can find circles of stones, patterned mounds, and solitary marker rocks that seem unassuming to an untrained eye. But these are the libraries and lecture halls of this ancient culture. A classic example is the Bora Ring. These are circular formations of earth or stone, often two concentric rings connected by a sacred pathway. While used for initiation ceremonies, their significance is deeply astronomical. The layout of these rings, the positioning of the pathway, and the specific stones within them are frequently aligned with celestial bodies, particularly the Southern Cross and the pointing stars of the Emu in the sky, a dark constellation formed by the dust lanes of the Milky Way. The appearance of this celestial emu at certain times of year would signal when to hold ceremonies or when emus were laying eggs, linking the cosmic event directly to a practical, ecological outcome. These stones were not just markers, they were the physical anchors of the songlines, permanent points of reference that grounded the ephemeral song in the solid, unchanging earth. What makes this approach so profound is its utter inseparability from daily life and law. This was not an academic pursuit conducted by a specialized few. Astronomy was embedded in everything. The stories sung along the songlines encoded not only navigation routes, but also the legal and moral codes for how to care for the country one was walking through, where to find water, which plants were in season, and how to interact with the land sustainably. The stone arrangements served as communal gathering points where this knowledge was passed down through generations. An elder teaching a young initiate would point to a stone that represented a star, tell the story of the ancestral being associated with it, and explain the lore connected to that part of the country. Art, ceremony, ecology, astronomy, and jurisprudence were all facets of the same brilliant, multifaceted gem of knowledge. It represents a worldview where to understand the universe is to understand your responsibilities within it, to see yourself not as a master of nature, but as a participant in a vast, ongoing creation story that is written equally in the stars and in the stones. This deep, spiritual connection to country and cosmos offers a powerful reminder that true understanding comes not just from observing the heavens, but from listening to the stories they tell and recognizing our place within them. Venturing into the misty highlands and windswept islands of northern Europe, we find a different kind of celestial artistry, one where stark, dramatic landscapes provided the stage for Norse and Celtic sky watchers. Here, the stone circles feel less like architectural monuments and more like organic extensions of the earth itself, rising from the peat and heather as if they'd always been there. The Callanish stones on the Isle of Lewis in Scotland are a breathtaking example. Unlike the more famous Stonehenge, Callanish feels wild and untamed, a complex cross-shaped arrangement of towering gneiss slabs with a solitary burial mound at its center. Its primary purpose was not to capture the sun, but to dance with the far more elusive moon. The central avenue of stones is precisely aligned to frame the southernmost rising point of the moon during its major standstill, that rare 18.6-year cycle. On a clear night when the moon is at this extreme point, it appears to skim along the horizon, seeming to glide directly down this stone-lined avenue, creating a spectacle of such profound accuracy that it speaks to centuries of patient observation. This lunar fascination was deeply woven into the mythology of these northern cultures. The Norse, for instance, told a story that explained the sun's daily journey across the sky, not with a chariot, as the Greeks did, but with a constant, desperate chase. They believed the sun was pursued by a giant, ferocious wolf named Skirl. To protect the sun and ensure its safe passage, powerful gods and giants were said to have placed great stones in specific configurations, creating a protective path that would guide and shelter it from the predator. In this worldview, the standing stones were not inanimate objects. They were frozen deities, petrified giants, or powerful talismans placed there by divine hands to maintain the cosmic order. The astronomical alignment was therefore also a sacred boundary, a magical ward against chaos. This beautiful blend of myth and measurement shows that for these communities, understanding a celestial cycle was only half the story. The other half was telling a story that gave that cycle meaning, danger, and purpose within their epic worldview. For the Celtic Druids, the learned class of priests, lawyers, and astronomers, these stone circles were active, living calendars that governed the rhythm of the entire year. The four great fire festivals Imbolc, Beltane, Lughnasadh, and Samhain marked the transitions between seasons, the turning points of the agricultural and pastoral year. The alignment of certain stones would have been crucial for pinpointing these dates with the precision required for a society dependent on the land. On the eve of Beltane, for example, which heralded the beginning of summer and the fertile season, a druid might watch from a specific point within a circle for the first rays of the May sunrise to strike a particular stone, signaling the time to light the great bonfires and drive cattle between them for purification. Similarly, the setting sun on Samhain, the festival that marked the end of the harvest and the beginning of the dark, winter half of the year, might be observed sinking between two pillars, confirming that the veil between the worlds was at its thinnest. These were not abstract celebrations. They were critical, calendrical events that dictated when to plant, when to harvest, when to breed livestock, and when to gather the community for law-giving and governance. The incredible durability of stone was the key to preserving this complex, interwoven system of knowledge across countless generations. In a culture that relied primarily on oral tradition, where all law, history, and science were memorized and recited, the stone circles served as permanent, immutable mnemonic devices. An elder teaching an apprentice wouldn't just tell them a story about the moon. They would take them to the circle and have them stand in a specific spot, watching a specific event, and then recite the myth, the law, or the agricultural rule associated with that precise alignment. The stone guaranteed that the event would happen exactly as predicted, year after year, century after century, providing a fixed physical anchor for an otherwise fluid oral culture. The circle itself became a classroom, a cathedral, and a court of law, all under the open sky. This ensured that even through periods of upheaval, migration, or cultural change, the fundamental knowledge encoded in the landscape, when to celebrate, when to sow, and how to navigate by the stars would endure, etched not on parchment, but on the very bones of the earth itself. When we look at these ancient stone circles and towering monuments, it's easy to focus on their spiritual or cultural significance and overlook the sheer mathematical brilliance they represent. These builders were master geometers working on a scale that boggles the mind. Without theodolites, GPS, or even written calculation, they achieved alignments with a precision that would be impressive even with modern tools. How did they do it? The answer lies in a profound, hands-on understanding of basic geometric principles, patient long-term observation, and a willingness to refine their work across generations. They didn't have our technology, but they possessed something equally powerful, a deep, intuitive connection to the land and the sky, and the ability to translate that connection into stone with stunning accuracy. The most fundamental tool in their kit was the humble peg and cord. This simple combination was the ancient world's equivalent of a compass and ruler. By driving a central peg into the ground and using a stretched cord to inscribe a circle around it, they could create a perfect geometric form. This technique is evident in the near-perfect circular layouts of sites like Stonehenge and the Ring of Brodgar. But their ambitions went far beyond circles. To create the complex rectangles and Pythagorean triangles that underpin many monuments, they used a method of triangulation that was both simple and brilliant. They would have set out a baseline using 3 stakes and a cord, ensuring it was perfectly straight. From there, they could use ropes knotted at specific intervals, perhaps in a 3-4-5 ratio, to create a perfect right angle. This is a direct, practical application of the Pythagorean theorem, centuries before Pythagoras was even born. They may not have had the algebraic proof, but they understood the spatial relationship intimately. This allowed them to lay out the precise rectangles found within Stonehenge's Sarsen circle, or the geometric patterns that define countless other henges across Europe. Achieving alignments with celestial bodies required another layer of sophisticated observation. To capture the solstice sunrise or the lunar standstill, they relied on a technique known as the foresight and backsight method. They would select a distant, natural feature on the horizon, like a distinctive notch between two hills, to serve as their foresight the target. Then, over years or even decades, they would observe the sun or moon rise from different vantage points until they found the exact spot where its appearance perfectly framed that notch. This spot would become the backsight, and it was here they would place a permanent stone marker. This process wasn't a one-time event. It was a continuous cycle of observation, adjustment, and refinement. A stone might be moved inches over the years as observations became more precise, with each generation building upon the knowledge of the last. The result was a permanent record of celestial movement, a stone computer programmed by the sky itself. The precision they achieved is what truly stuns modern researchers. At Newgrange, the roof box that admits the winter solstice sun is aligned with such exactness that the beam of light travels a 62-foot passage to illuminate the chamber for just 17 minutes. The error margin is vanishingly small. Similarly, the Great Pyramid of Giza is aligned to the cardinal directions with an accuracy of within 1/15th of a single degree. This isn't guesswork, it's empirical science of the highest order. They relied on repetitive observation, logging the movements of celestial bodies over lifetimes to average out errors and pinpoint true patterns. This long-term dedication transformed their understanding from simple noting of events into a predictive science. They began to see the patterns behind the patterns, allowing them to not just mark the solstice, but to predict eclipses and understand the moon's complex 18.6-year cycle. This level of precision forces us to completely reevaluate what we think of as prehistoric capabilities. These were not primitive people fumbling in the dark. They were innovative problem solvers, applying a rigorous, methodical approach to understanding their universe. They used the tools they had: stone, cord, wood, and most importantly, their own intellect and patience to solve complex astronomical and engineering problems. Their achievements stand as a powerful testament to human ingenuity, proving that a deep understanding of the cosmos is not dependent on technology, but on careful observation, a mastery of geometry, and the unwavering desire to bring the infinite heavens down to earth, one perfectly placed stone at a time. While the precise alignments and geometric layouts of these ancient sites reveal a formidable scientific intellect, to view them solely as instruments of measurement is to miss their deepest purpose. For the cultures that built them, every stone was a word in a larger story, a physical embodiment of a cosmic truth that connected the everyday world to the divine. These weren't just observatories, they were sacred landscapes where the boundary between the earthly and the celestial became thin, and every alignment was a verse in a grand, sung poem about the nature of existence. The stone that marked the solstice sunrise wasn't merely a calendar marker. It was often seen as the petrified form of an ancestor who first taught the people about the sun's journey, or a deity frozen in time holding up the edge of the sky. In this worldview, a rock could be a living entity, imbued with a spiritual power known as mana in Polynesian traditions or ash in some African beliefs, acting as a permanent battery of sacred energy and a conduit for communication with the gods. This profound symbolism is beautifully illustrated in traditions that are still alive today. In Islam, the black stone embedded in the corner of the Kaaba in Mecca is deeply venerated. While its primary religious significance is profound, it also holds an important astronomical connection. The Kaaba itself is a major orienting point for prayer, and its original construction is linked to celestial events. Some Islamic traditions and historical accounts suggest its alignment was set with certain astronomical phenomena in mind, connecting the earthly act of worship to the cosmic order. Similarly, the intricate design of Hindu temples is a masterclass in symbolic stonework. These structures are conceived as literal maps of the cosmos, with their layout and alignment dictated by sacred Vastu Shastra texts that are deeply intertwined with Vedic astrology. The central shrine, the Garbhagriha or womb chamber, is positioned based on precise astrological charts to harness specific celestial energies. The stones themselves are not inert building materials. They are carefully selected and consecrated to become vessels for the divine presence, ensuring the entire temple functions as a spiritual instrument aligned with the universe. This layered meaning transformed the entire landscape into a text to be read. A mountain peak on the horizon that framed the midsummer moon wasn't just a convenient foresight. It was a mythological character, perhaps the brow of a sleeping giant. A solitary standing stone in a field might be seen as the axis mundi, the world pillar connecting the underworld, the earth, and the heavens. In Mesoamerica, the ceiba tree held this role, but it was often represented by a central stone in a plaza. For the Maya, the world was a square, flat plain with this great world tree at its center, and their pyramids were man-made mountains and symbolic world trees, with their stairways representing the path the gods took to descend to earth. Every astronomical alignment, therefore, told a story of creation and order. The winter solstice wasn't just the sun's rebirth. It was the reenactment of the moment the Creator God defeated the forces of darkness. An eclipse was not merely a celestial event. It was a dramatic and often terrifying chapter in the ongoing battle between cosmic forces, requiring human ritual and intervention at these stone conduits to restore balance. Understanding this rich symbolic layer completely transforms our appreciation of these sites. It shows us that ancient astronomy was never a cold, detached science. It was a holistic practice that wove together empirical observation with spiritual belief, artistic expression with communal law, and practical necessity with profound philosophical inquiry. The builders of Stonehenge or the arrangers of the medicine wheels were not just astronomers and engineers. They were theologians, artists, and storytellers. They sought not only to predict the seasons but to understand humanity's place within a living, breathing, and sacred cosmos. The stones were their language and the sky was their scripture, and by reading both together, they found a purpose and an order that guided their lives for generations. Imagine for a moment the immense responsibility of being the human library for your entire culture. In a world without hard drives or written records, the most sophisticated astronomical data ever gathered, the precise timing of an eclipse cycle, the 18.6-year path of the moon, the rising point of a star that signals the monsoon rains, all of it resided solely in the memory of a select few individuals. This was the reality for ancient astronomers, and their method of preserving and transmitting this priceless knowledge was not through books, but through a living chain of oral tradition and direct apprenticeship. This was a system built not on paper, but on trust, ritual, and the incredible power of the human mind. The stones themselves were the permanent, unchanging hardware, but the elders and shamans were the software, the living, breathing programs that knew how to operate them. The primary classroom was the sacred site itself. Learning wasn't done by reading a text. It was an immersive, experiential process. A young apprentice would accompany an elder to a stone circle at dawn on the winter solstice. They wouldn't just be told that the sun would rise over a certain stone. They would stand in the freezing cold, watching the horizon, feeling the anticipation build until that first sliver of light erupted exactly where the elder said it would. This created a powerful multisensory memory, tying the astronomical event to a specific place, a specific feeling, and the revered presence of their teacher. The knowledge was passed down through stories and songs that served as sophisticated mnemonics. A complex series of star positions might be encoded in the journey of an ancestral hero, with each twist and turn in the tale corresponding to a shift in the celestial pattern. These narratives transformed dry data into epic poetry, making it not only easier to remember but also imbuing it with cultural and spiritual significance that ensured it was considered far too valuable to be lost. This system of knowledge transfer was incredibly effective, but it was also fragile and exclusive. In cultures like the Druids of Europe or the Aboriginal elders of Australia, this astronomical wisdom was often considered sacred and powerful, not to be shared freely. It was closely guarded, taught only to those who had undergone rigorous initiation and proven their worthiness. This selective sharing wasn't about hoarding knowledge out of spite, it was a protective measure. In the wrong hands, the ability to predict an eclipse or a solstice could be used to manipulate and control people, to claim false divine authority. By controlling this knowledge, the elders maintained not only its accuracy, but also the social and spiritual stability of the community. The apprentice wasn't just learning facts, they were being entrusted with the spiritual well-being of their people, a weighty responsibility that ensured they approached their studies with the utmost seriousness and reverence. This mentorship was the essential thread that connected generations, allowing an observation made by a great-grandparent to be verified and refined by their descendants centuries later, creating a living, evolving science that was sustained by the most human of connections, the bond between teacher and student. While the enduring power of stone allowed ancient cultures to build calendars that would last for millennia, their astronomical curiosity wasn't limited to these massive, permanent installations. The human mind craved both the grand, public spectacle and the intimate, portable tool. This led to a fascinating parallel development of instruments crafted from more perishable materials like wood, bone, and metal, each serving a unique and vital purpose in the quest to understand the heavens. Imagine an ancient Babylonian astronomer not standing at a stone circle, but sitting in a clay brick library, using a sharp stylus to impress careful observations of Venus onto a soft clay tablet. Once fired, that tablet became a permanent, if fragile, record, a database of celestial movements that could be stored, referenced, and even mailed to other cities. This was astronomy on a personal, administrative scale, a world away from the communal solstice sunrise at Stonehenge, yet equally important for advancing knowledge. The advantages of these alternative materials were all about flexibility and portability. A Greek or Islamic scholar centuries later could carry a beautifully crafted brass astrolabe, a complex device often called the smartphone of the Middle Ages. This intricate instrument, with its rotating discs and finely etched coordinates, could tell the time, calculate the altitude of stars, and even determine latitude, all from the palm of one's hand. It represented a movable heaven, a model of the cosmos that could be consulted anywhere, anytime. Similarly, the Vikings are believed to have used sun shadow boards made of wood, a portable navigation tool that helped them traverse the open ocean by measuring the sun's height. These devices offered a different kind of power, not the eternal, fixed power of a stone alignment, but the dynamic, immediate power of calculation and navigation that could travel with an individual. This created a beautiful and practical coexistence of tools across the ancient world. A culture might have its great stone circle for marking the solstices and determining the agricultural year, a function that required communal participation and permanent accuracy. But that same culture's learned elders might also use a wooden measuring rod or a notched bone tally to count the days between lunar phases or to calculate more complex cycles in private. The stone structures provided the unchanging foundational calendar for the entire society, while the portable tools allowed for more detailed, personal, or specialized computation. One was the public clock tower, the other was the personal wristwatch. This diversity highlights the incredible creativity and adaptability of pre-modern scientists. They weren't limited by a lack of modern technology. Instead, they looked at the resources available to them, whether it was a granite slab, a piece of ivory, or a lump of bronze, and asked, "How can I use this to better see the sky?" The result was a rich tapestry of innovation where every material, from the most permanent to the most ephemeral, was bent to the service of astronomy. For all their breathtaking genius, the ancient astronomers who raised these stone sentinels to the sky were not working with limitless resources or perfect conditions. They battled against the relentless forces of nature and the inherent constraints of their own technology, making their achievements all the more remarkable. The very stones they relied on for permanence were themselves vulnerable. Imagine the deep frustration after years of careful observation and backbreaking labor to erect a monolith, only to have a violent storm or a minor earthquake shift its foundation by a few critical inches. That tiny deviation could throw off an alignment it took a generation to perfect, rendering a sophisticated solar marker useless. In coastal regions, salt spray and wind could slowly erode the sharp edges of a sighting stone, blurring the precise line needed to frame a star's rising. Frost and thaw cycles in colder climates could gradually heave stones from their original positions, a slow, imperceptible drift that would only be noticed when the celestial event failed to occur as predicted. These were constant, silent battles against entropy, requiring a society committed not just to building these monuments, but to their perpetual guardianship and maintenance. The sheer physical logistics of their construction presented another monumental hurdle. The story of moving a 80,000-pound sarsen stone from the Marlborough Downs to Stonehenge is the stuff of legend, but it underscores a daily reality of immense effort. Without the wheel or draft animals, transport relied on human power, log rollers, rope made from plant fibers, and a profound understanding of leverage. This was a staggering investment of time and calories for a community that likely lived on the edge of subsistence. A single failed attempt to move a stone, an accident that resulted in a cracked monolith, could represent a catastrophic waste of communal energy. The choice of location was also a constant negotiation between ideal astronomical sightlines and practical reality. A perfect hilltop for viewing might be too far from the quarry or lack sufficient water for the workers. The grandest designs were often tempered by what the local landscape could actually provide, forcing ingenious adaptations and compromises. Perhaps the most subtle and insidious challenge was the accumulation of tiny errors. Their entire science was built on a foundation of naked eye observation. The human eye is a wonderful instrument, but it is not a precision tool. Judging the exact moment the sun's upper limb breaks the horizon on a hazy morning, or pinpointing the rise of a star against a slightly blurred horizon due to heat haze, introduced minute inaccuracies. Over decades, these small observational errors could compound, much like a watch that loses a few seconds each day. A solstice alignment that was perfect for a grandfather might be noticeably off for his grandson. This required a culture capable of self-correction, where new generations were empowered to carefully nudge a stone back into place or even, in some cases, undertake a partial rebuild to restore the site's celestial accuracy. This was a science that had to be alive, constantly verified and adjusted against the sky itself. Finally, these stone libraries were vulnerable to the most unpredictable element of all, human history itself. Sites like Chaco Canyon or the great Mayan cities stand as silent testimonials to this fragility. A prolonged drought, a shift in trade routes, war, or social upheaval could lead to the abandonment of a ceremonial center. When the community that served as the living memory of a place disperses, the knowledge encoded in its stones becomes a locked book. The specific oral traditions, the songs that explain the meaning of a particular shadow, the apprenticeship chains that taught how to read the sun dagger, all of it could vanish within a generation or two. The stones remain, but their operating manual is lost for centuries, leaving later archaeologists to painstakingly reverse engineer their purpose. This vulnerability reminds us that the true instrument was never the stone alone. It was the unbroken chain of human curiosity and dedication that gave it meaning, a chain that could be broken by the harsh realities of a changing world. For centuries, the true purpose of these ancient stone arrangements was shrouded in mystery, often dismissed as primitive ritual sites or the haphazard work of superstitious cultures. The idea that our ancestors could have possessed such sophisticated astronomical knowledge seemed, to many, like a fanciful modern projection. But then a new scientific discipline emerged, armed with tools that could finally listen to what the stones had been whispering all along. This field is archaeoastronomy, a marriage of archaeology and astronomy, and it has fundamentally rewritten our understanding of humanity's ancient past. By applying the rigorous methods of modern science to these age-old monuments, researchers have moved beyond speculation into a world of verifiable, stunning precision, confirming that the celestial alignments we've been discussing were not accidental but the entire point of these colossal endeavors. The technological arsenal of the modern archaeoastronomer is a world away from the simple Nomen and sighting line. Today, laser scanning technology can create millimeter-perfect 3D models of an entire site, capturing every nuance of its orientation and the subtle inclinations of each stone. Using high-precision GPS, researchers can plot the exact geographic coordinates of these monuments, and then, with sophisticated computer software, run simulations that roll back the celestial clock thousands of years. This allows them to see the night sky exactly as the builders would have seen it, accounting for tiny shifts in the Earth's axis over millennia. It's this last point that is so critical. A star that rises over a particular hill today would have risen in a slightly different position 4,000 years ago. These digital tools allow us to erase that error and witness the original, intended alignment in all its glory. This isn't just guesswork, it's a data-driven reconstruction that has settled long-standing debates. At Stonehenge, for instance, this technology has not only confirmed the solstice alignments, but has also revealed more complex patterns related to the moon, suggesting the site was a comprehensive astronomical calculator. Beyond the sky, other scientific techniques help us understand the human story behind the stones. Carbon dating of organic materials found in construction layers, a piece of antler used as a pick, charcoal from a builder's campfire provides a reliable timeline for when these structures were erected. Geological analysis can trace a stone back to its exact quarry, revealing incredible journeys like the 250-mile transport of the Stonehenge bluestones, a feat that speaks volumes about the cultural importance of the project. But perhaps the most poignant validation comes from ethnographic research, where scientists work directly with the living descendants of the monument builders. In the American Southwest, Hopi and Pueblo elders have provided invaluable context for the patterns at Chaco Canyon. explaining the oral traditions and cosmological beliefs that turn a petroglyph from an abstract carving into a chapter of a living story. This interdisciplinary approach, blending hard data with cultural knowledge, transforms these sites from silent ruins into vibrant places of learning and worship. The impact of this validation cannot be overstated. It forces a dramatic re-evaluation of so-called primitive societies. These were not people simply struggling to survive. They were brilliant scientists, engineers, and philosophers who dedicated generations to a single grand project of understanding. Their achievements stand as a powerful testament to the universal human drive to find order in the cosmos. Modern science, rather than diminishing their accomplishments, has become the very tool that allows us to finally appreciate their full genius, building a breathtaking bridge across time that connects our curiosity directly to theirs. The legacy of these ancient stone watchers is not confined to the past. It is a living foundation upon which our modern understanding of the cosmos is built. Those first patient observations of cyclical patterns carved into the landscape established a fundamental principle that would become the bedrock of all science. The universe operates according to predictable, observable laws. This idea that the heavens were not a realm of capricious magic but of orderly repetition was the crucial first step. It was this foundational belief that Greek philosophers and astronomers would later inherit and expand upon, transforming those empirical observations into formalized theories of spherical astronomy. Thinkers like Aristarchus and Eratosthenes didn't emerge from a vacuum. They stood on the shoulders of generations of anonymous sky watchers who first dared to measure what they saw. The Greek innovation was to take the data encoded in stone circles and translate it into geometric models, creating a more abstract but powerfully predictive understanding of the celestial sphere. This thread of influence weaves directly through history into the heart of the Renaissance, a period defined by its rebirth of classical learning and its fervent embrace of direct observation. When Copernicus looked up at the sky and proposed a heliocentric model, he was participating in the same human endeavor as the builders of Newgrange, questioning humanity's place in the cosmos based on the evidence of his eyes. Galileo's refinement of the telescope was not a rejection of these ancient methods, but a monumental extension of them. He simply offered a new, more powerful tool for the age-old practice of sighting and alignment, allowing him to see the moons of Jupiter and the phases of Venus, thus providing the crucial evidence that would shatter the ancient geocentric view. The scientific method itself, with its core tenets of observation, hypothesis, and verification, is the formalized, institutionalized descendant of the process those ancient astronomers perfected through trial and error over centuries. They observed the sun's wandering path along the horizon, hypothesized that a specific stone alignment could mark its extreme turn, and verified it by returning year after year to see if the light struck true. Our daily lives are still governed by the practical applications they pioneered. The modern calendar we use to schedule our meetings and plan our holidays is a direct inheritance from those early solar and lunar observations, refined through Roman and later Christian revisions, but rooted in the need to track seasons for survival. The very concept of navigation by the stars, which allowed explorers to map the globe, was first practiced by Polynesian voyagers using stone maps and songlines, and by other cultures using horizon markers. Today, the stones themselves have taken on a new role as bridges between the past and present. Sites like Stonehenge and Chaco Canyon are not merely tourist attractions. They are outdoor laboratories for interdisciplinary research and powerful catalysts for public wonder. They draw people from all over the world, not just to take a photo, but to experience a tangible connection to human history and to share in the universal awe of the cosmos, a feeling that transcends time and culture. Perhaps the most vital and exciting aspect of this legacy is the ongoing revitalization of indigenous astronomical knowledge. After centuries of suppression and dismissal, the wisdom held in oral traditions, stone arrangements, and ceremonial practices is being recognized not as myth, but as a sophisticated and valid way of knowing. Scientists are now collaborating with indigenous elders to understand traditional ecological knowledge, which is often deeply tied to celestial cycles. This partnership is enriching modern astronomy, offering new perspectives and long-term datasets that stretch back millennia, recorded in story and song. For indigenous communities themselves, this revival is a powerful source of cultural pride and resilience, a reclamation of identity and a reaffirmation that their ancestors were brilliant scientists who read the night sky as a familiar and guiding text. This enduring quest, from the first stacked stone to the latest satellite telescope, reveals a profound and timeless human drive to find our place in the universe, a story whose first chapters were written not on paper, but in the enduring language of stone. This deep, ancient connection between humanity and the heavens, so beautifully expressed in stone, invites a profound philosophical question that is perhaps more relevant today than ever before. How did our ancestors see their place in the universe, and what can that teach us about our own? The world view revealed by these astronomical sites is one of radical interconnectedness, a vision where people were not mere observers of the cosmos but active, participatory players within a grand, ordered system. This stands in stark contrast to a more modern perspective, which often positions humanity as separate from nature, using science as a tool for mastery and control over our environment. For the builders of stone circles and solar temples, the goal was not to conquer the natural world but to harmonize with it, to find their rhythm within the universal pulse. This fostered a powerful sense of humility. They understood that their survival depended on correctly reading the signs of the seasons, the stars, and the sun, acknowledging forces far greater than themselves. This wasn't a humility born of weakness but of wisdom, a recognition that they were threads in a vast, living tapestry, not weavers outside of it. This holistic view naturally wove together what we now often keep in separate boxes: empirical science and spiritual meaning. There was no conflict between measuring the precise angle of a solstice sunrise and believing that event to be the breath of a god. The observation was the prayer and the data was the scripture. At Newgrange, the mathematical precision that allows light to travel a 62-foot passage is itself a spiritual act, a dramatic reenactment of rebirth that feeds the community's soul. The Inca priests reading the shadows on the Intihuatana stone were simultaneously calculating the optimal time for planting and communicating with the sun god Inti. This fusion created a powerful sense of responsibility. If your rituals and observations were what kept the sun returning and the crops growing, then your role as a human carried immense weight. You were a custodian of cosmic order, a maintainer of balance. This sense of duty was directed not only toward the gods but toward the community and the land itself, fostering a culture of sustainability and reverence for the resources that sustained life. The lessons embedded in this ancient stone for our modern world are both urgent and deeply poetic. In an era defined by environmental crisis and a feeling of disconnection, this old way of seeing offers a different path. It suggests that sustainability is not just a technological problem to be solved with better engineering, but a philosophical and spiritual one. It asks us to move beyond seeing nature as a collection of resources to be managed and instead to see ourselves as part of an ecological whole with a responsibility to maintain its balance. The drive to preserve cultural heritage sites is in itself an echo of this ancient impulse, a recognition that these places hold a wisdom that is not just historical but essential. They are tangible reminders that a purely detached objective science, while powerful, can sometimes lack a heart. It can tell us how the world is changing, but it doesn't always tell us why we should care. The ancient astronomers would argue that we care because we are not separate from the world we study. We are of it. Their stones whisper a message of unity, that the health of the earth and the health of the human spirit are inextricably linked, that the past is not dead but speaks to the present, and that the sky above is not a cold void but a familiar home we share with all of humanity across time. Standing in the shadow of a 5,000-year-old stone, feeling the same solstice sun warm your face that a Neolithic builder once felt, is an experience that transcends any history book. It's a profound, almost electric connection to the past, a moment where the gap of millennia suddenly narrows to nothing. To visit these ancient astronomical sites is to walk directly into the Astronomers Quarry, to see the tools of cosmic measurement not as abstract concepts, but as the physical, weathered reality of the landscape. You can trace the sight lines with your own eyes, from the central altar stone to the distant horizon notch, and in that act, you participate in the same act of observation that defined these places. It's a transformative journey that turns academic knowledge into a deeply personal understanding. With this incredible privilege of access, however, comes a profound responsibility: the practice of ethical tourism. These are not theme parks, they are fragile, non-renewable cultural treasures, and for many, they remain deeply sacred spaces. Respecting local guidelines is the first and most crucial step. This means staying on marked paths, not climbing on the stones, and following photography rules. The oils from our hands, the erosion from our feet, and even the subtle vibrations of too many people can cause irreversible damage to structures that have endured for 50 centuries. Our visit should be an act of preservation, not one of attrition. Supporting preservation efforts directly is another powerful way to be an ethical traveler. This can be as simple as paying the entrance fee, which funds vital conservation work, or donating to organizations dedicated to protecting these sites from environmental and human threats. Perhaps the most enriching dimension of an ethical visit is to actively seek out and learn from indigenous perspectives where they are available. At places like Chaco Canyon or numerous sites in Australia, the descendants of the builders are often involved in stewardship and education. Choosing a guided tour led by a member of the local community or an indigenous archaeologist doesn't just provide facts, it provides meaning. You'll hear not only about the engineering behind a solstice alignment, but also the stories, songs, and spiritual beliefs that are intertwined with that astronomical event. This approach transforms a sightseeing trip into a genuine cultural exchange, fostering respect and ensuring that the living legacy of these places is honored, not just their ancient history. For those who cannot make the journey in person, modern technology offers a remarkable alternative. Many of these sites now have extensive virtual tours available online, allowing you to navigate the stone circles of Callanish or the passages of Newgrange from your home. High-resolution photography, 3D models, and interactive exhibits in museums around the world use digital tools to bring these wonders to life in stunning detail. While it's a different experience from feeling the wind on your face at the site, these virtual access points are invaluable for education and inclusion, ensuring that the story of the Astronomers Quarry can inspire a global audience. They also serve as a vital preservation tool, creating detailed digital records for future generations and allowing for rest and recovery for the physical sites themselves. Whether you visit in person or online, engaging with these places ultimately deepens our collective appreciation for human ingenuity, reminding us that the timeless allure of the stars has always been a powerful force in uniting us across time and culture. What if the greatest innovation in modern science isn't a new technology, but a very old perspective? The methods of those ancient sky watchers, honed over millennia, offer a powerful blueprint for tackling some of today's most complex challenges. Their approach wasn't built on specialization and isolation, but on three profound principles we often overlook: long-term observation, genuine community collaboration, and fearless interdisciplinary thinking. They understood that to decode the cosmos, you needed to commit to a project longer than a single lifetime. You needed the collective knowledge of the entire community, from the farmer noticing a subtle shift in the starry backdrop to the elder remembering an ancestor's story about an eclipse. And you needed to weave together practical geometry with spiritual belief, art with engineering, ecology with architecture. This holistic way of knowing stands in stark contrast to our modern tendency to silo knowledge into separate, disconnected boxes. We can begin to reintegrate this wisdom by bringing it into our classrooms. Imagine a geometry lesson that doesn't start with a textbook, but with a virtual tour of Stonehenge. Students could measure the angles of the trilithons, calculate the circumference of the Sarsen circle, and then explore the astronomical alignments those geometries make possible. This isn't just math, it's applied math with a story. A history class could use the sun dagger at Chaco Canyon as a gateway to understanding ancestral Puebloan culture, their agricultural practices, and their sophisticated trade networks. An environmental science course could study how the Aboriginal songlines encode intricate knowledge of seasonal changes, animal migrations, and sustainable land management, offering a masterclass in ecology that is thousands of years old. This approach, often called archaeoastronomy, transforms abstract subjects into a thrilling, interconnected detective story, showing students that knowledge is a living, evolving web, not a series of isolated facts to be memorized. Beyond the classroom, modern astronomers are increasingly using these ancient sites as powerful tools for public engagement. There's a palpable magic in standing at an ancient observatory and looking at the same stars its builders studied. Organizations now host star parties and solstice events at places like Callanish or Newgrange, where astronomers with telescopes stand beside archaeologists and local storytellers. This creates a beautiful dialogue between past and present, where the latest discoveries about exoplanets are discussed in the shadow of stones that track the wanderings of Venus. It powerfully demonstrates that science is not a destination but a continuous journey of inquiry, one that connects an iPhone app predicting a satellite pass to a Mayan priest charting the cycles of the moon on a stone tablet. This connection builds trust and wonder, reminding the public that science is a fundamentally human endeavor. Perhaps the most forward-thinking application of this ancient knowledge is in the field of sustainable design and architecture. The same sun that Neolithic builders harnessed to mark the solstice is now being captured by photovoltaic panels, but the principle of alignment remains unchanged. A new wave of architects is looking to these ancient principles for inspiration, designing buildings that are passively aligned with the sun's path to maximize natural light and heat, drastically reducing their energy needs. This isn't just high-tech, it's a return to a deep-time wisdom about working with natural cycles rather than against them. Urban planners are studying the layout of ancient cities like Chaco Canyon, which was meticulously designed to integrate with its environment and celestial patterns to inspire more resilient and harmonious community designs. By blending this ancient spatial intelligence with contemporary materials and needs, we can create a built environment that is both cutting-edge and deeply sustainable, proving that the most innovative solutions are sometimes found by looking back at the original instructions written in stone and sky. This legacy shows us that the past is not a closed book but a living library, offering timeless lessons on observation, collaboration, and integration that can guide us toward a more thoughtful and connected future. It's incredibly tempting to look at a structure like the Great Pyramid or the precision of the Sun dagger and reach for an otherworldly explanation. The idea that ancient aliens must have provided the technology or that these were built by a lost, hyper-advanced civilization is a popular and seductive myth. But this line of thinking, however thrilling it might seem, actually does a tremendous disservice to the true marvel of human history. It robs our ancestors of their genius, writing off their accomplishments as something they couldn't possibly have achieved on their own. The reality is far more impressive. These were not passive recipients of alien knowledge. They were brilliant, observant, and immensely patient scientists and engineers, working with the resources and the intellect they possessed. They didn't need outside help. They had something far more powerful: generations of dedicated observation and a deep cultural commitment to understanding their world. The mystery often stems from a modern perspective that underestimates just how much can be accomplished with simple tools, time, and meticulous record-keeping. We live in an age of instant gratification and rapid technological change, so the concept of a project that takes 200 years to complete is almost incomprehensible to us. But for these cultures, this was normal. A master stonemason would teach his son, who would teach his grandson, the knowledge passed down orally and through practical apprenticeship. A slight error in an alignment noticed by one generation could be corrected by the next. This long-term investment in a single, sacred goal allowed for a slow, deliberate accumulation of precision. They used basic tools like wooden pegs, stretched cords, and nomens to create perfect right angles and circles. They used the horizon itself as a giant protractor, noting the sun's shifting rise and set points against notches in distant hills with incredible accuracy. What appears mysterious to us was, for them, the product of painstaking, repeatable science conducted over centuries. Furthermore, these myths often ignore the rich cultural and spiritual context that made such Herculean efforts not just possible, but essential. Moving an 80-ton stone wasn't just an engineering challenge. It was an act of deep faith, a communal endeavor that reinforced social bonds and honored the gods. The celestial events they tracked were not abstract data points. They were the heartbeat of their existence, dictating the agricultural cycle, the timing of sacred ceremonies, and the very framework of their cosmology. This powerful motivation provided the driving force for the immense labor required. When you believe that correctly aligning a temple with the solstice sunrise is what ensures the sun will return and the crops will grow, no amount of effort is too great. The stones are a testament to that profound belief, a physical manifestation of their desire to live in harmony with the cosmic order. Ultimately, debunking these myths doesn't make the accomplishments of ancient astronomers any less wonderful. It makes them infinitely more so. To acknowledge that humans alone, using Stone Age technology, could achieve such feats is to celebrate the boundless potential of human ingenuity, cooperation, and curiosity. It connects us to them in a more meaningful way. They were not so different from us. They simply asked the same questions with a different set of tools. Their work doesn't compete with modern science. It forms its very foundation. Every time an archaeoastronomer uses a laser theodolite to confirm a solstice alignment that was first found with a wooden pole, it's not a contradiction. It's a continuation of the very same human quest for knowledge. By letting go of the fantastical stories of aliens and lost empires, we can finally see the true story, one of incredible human achievement, written in the enduring language of stone and light. Our journey into the Astronomers Quarry brings us to a powerful conclusion. one that reshapes our understanding of human history and our place in the cosmos. We've traveled across continents and millennia, from the Saharan sands of Plier to the rain-swept stones of Kalanish, from the towering pyramids of Giza to the sun-drenched cliffs of Chaco Canyon. At every stop, we've found the same incredible story written in stone, a story of human curiosity, ingenuity, and an unshakable desire to comprehend the heavens above. These ancient monuments were far more than primitive calendars or ritual sites. They were humanity's first observatories, our first laboratories, our first complex scientific instruments. Without lenses or brass fittings, without written formulas or digital calculations, our ancestors turned the very landscape into a precise tool for measuring the universe. They used patience as their method and stone as their medium, achieving a level of accuracy that still commands our respect and wonder today. What emerges from this global tapestry is a profound universal truth about the human spirit. Separated by oceans and mountains with no means of communication, cultures across the world independently looked upward and asked the same fundamental questions. They saw patterns in the chaos, cycles in the apparent randomness, and they felt compelled to mark, measure, and honor these celestial rhythms. This wasn't merely practical, though it certainly guided their agriculture and navigation. It was deeply philosophical and spiritual. They understood that their lives were intertwined with the motions of the sun, moon, and stars, and they built these magnificent structures to physically manifest that connection, to anchor their communities to the dependable pulse of the cosmos. In doing so, they laid the groundwork for all of modern science, establishing the core principle that the universe operates by knowable, observable laws. As we peer into the depths of space with our orbiting telescopes and listen for the faint echoes of the Big Bang, it is humbling to remember that our quest began with a single stone placed carefully on a barren plain. The legacy of these ancient astronomers is not confined to history books. It lives on in our continued exploration of the universe. Their spirit of inquiry fuels our missions to Mars, their meticulous observation underpins our scientific method, and their sense of wonder still draws our eyes to the night sky. They teach us that science and spirituality need not be opposed forces, but can be complementary ways of engaging with the profound mystery of existence. They remind us that true understanding often requires not just advanced technology, but patience, collaboration, and a deep reverence for the world around us. This exploration of historical mysteries doesn't end here. If this journey through the Astronomers Quarry has sparked your curiosity, we invite you to share your own thoughts and reflections in the comments below. What sight captured your imagination the most? Have you ever witnessed a solstice alignment or tried to track a celestial event yourself? Your stories and questions are what make this community so vibrant. And if you want to join us for more adventures into the forgotten corners of history, be sure to subscribe and turn on notifications. We're just getting started uncovering the incredible achievements of our ancestors. Thank you for spending this time exploring the cosmos through ancient eyes. May your own observations of the sky be filled with the same sense of wonder that moved those first astronomers to raise their stones to the heavens. Look up tonight and remember you are part of a story that began thousands of years ago, a story written in the stars and etched in stone.